the vast stretches of the cosmos. It's easy to think of space as just an enormous, dark, empty void, an expanse of nothingness between planets, stars, and galaxies. For centuries, this has been our prevailing assumption of the universe: vast distances of empty space, sparsely populated by occasional celestial bodies. However, modern science has revealed that space is far from empty. The notion of a true vacuum, a region completely devoid of matter and energy, does not exist. What may seem like emptiness is actually teeming with hidden energy, particles, fields, and phenomena that challenge our understanding of what nothingness truly is, and if nothing can even exist. One of the clearest reasons space is not empty is the presence of the interstellar and intergalactic medium, which fill the gaps between stars and galaxies respectively. Despite appearing to be void of any matter, these immense regions of space are actually composed of sparse gas, dust, and plasma. These particles are spread incredibly thin, far more than even the best vacuum we can create on Earth, but still exist in vast quantities across the universe. In the interstellar medium, gas molecules, predominantly hydrogen and helium, are spread out, often existing at only a few atoms per cubic centimeter. Although this may seem sparse, when you consider the enormous volume of space between the stars, the interstellar medium collectively adds up to a significant amount of mass. These atoms play a crucial role in the life cycle of stars, as they are the raw materials that form new stars and planetary systems. Regions of denser gas can collapse under gravity to form nebulae, which then gives birth to stars. The intergalactic medium is even more tenuous than the interstellar medium, with particle densities often 100 times lower. It is filled with hydrogen gas as well as traces of heavier elements, providing insights into the large-scale structure of the universe. These particles act as tracers for dark matter and help us understand how galaxies form and evolve. Another reason space is not empty comes from quantum mechanics. Even in the coldest, most barren stretches of the universe, where there may be no detectable matter for billions of kilometers, space is still far from empty. Quantum fluctuations result in particles spontaneously popping in and out of existence, even in a vacuum. These fleeting particles, known as virtual particles, exist for only the tiniest fractions of a second before annihilating each other, leaving no lasting trace except for their influence on the fabric of space itself. Virtual particles emerge from the uncertainty inherent in quantum mechanics. According to the Heisenberg uncertainty principle, energy and time are related in such a way that energy can fluctuate enough to create particle-antiparticle pairs out of nothing. This phenomenon is sometimes referred to as the quantum foam, a seething, chaotic state where energy momentarily bubbles up to create virtual particles that almost immediately disappear. This constant fluctuation of particles and energy gives rise to a phenomenon called the Casimir effect, in which two closely spaced metal plates in a vacuum can be pushed together by the energy of virtual particles. The Casimir effect is just one piece of evidence that the quantum vacuum is not truly empty, but is instead full of dynamic energy and activity. Even more mysterious than quantum fluctuations are dark matter and dark energy, two components that together make up about 95% of the total mass and energy content of the universe. Neither dark matter nor dark energy interact with light in a way we can directly detect, making them invisible to us. However, their presence is inferred through their gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Dark matter is thought to be responsible for the additional gravitational pull observed in galaxies and galaxy clusters. Without dark matter, galaxies would not have enough mass to prevent them from flying apart as they rotate. Although dark matter remains undetected by any direct means, its gravitational influence is undeniable, making it a significant component of the space throughout the universe. Dark energy is even more mysterious. It's believed to be the force driving the expansion of the universe. While space itself expands, dark energy seems to permeate every part of it, exerting a repulsive force which counteracts gravity. Although we do not fully understand what dark energy is or how it works, it fills the cosmos and dominates the universe's total energy. Another indication that space is not empty is the presence of the cosmic microwave background radiation. This faint glow is the afterglow of the Big Bang, the moment when the universe began to expand from an extremely hot, dense state. The CMB is the remnant heat from that initial explosion, now cooled to just 2.7 degrees above absolute zero. It bathes the universe in a faint but pervasive electromagnetic radiation. Even in regions of space that appear empty, the CMB is there, providing crucial information about the early universe. The slight fluctuations in the temperature of the CMB have allowed scientists to map the distribution of matter shortly after the Big Bang, offering insights into how galaxies and large-scale structures formed over time. Perhaps the most distinctive reason space is not empty is because it is filled with the very fabric of space-time itself. Einstein's theory of general relativity revolutionized our understanding of space, showing that space and time are not separate static entities. They are a dynamic, interconnected fabric that can be bent, stretched, and warped by the presence of mass and energy. Even in the absence of matter, space-time exists, and its curvature influences the motion of objects and the behavior of light. Gravitational waves caused by violent cosmic events like colliding black holes provide further evidence that space is not an empty void. These waves travel across the universe, distorting space-time as they move through the cosmos. This shows that even empty space can be affected by and transmit energy across vast distances. The idea of space being an empty void gives way to a more complex and vibrant reality, one that challenges our understanding of the cosmos and reveals that the universe is more intricate and interconnected than it might initially seem. To our eyes, space may appear to be filled with nothing, but it is in fact filled with a vast array of particles and activity that we are continuing to discover. Nothing may be a concept that human beings manufactured,